everyone. Today I'm really excited to talk to you about confidential computing and particular how it applies to the Kubernetes Control Plane in managed clusters. Before we get going, just a little bit of intro to myself. My name's Dinesh, I am CTO at Civo, and I've actually got 15 years of experience in the hosting industry, from running small domain names and their free email hosting, all the way up to now the public cloud that we're running here at Civo. In particular interest is security for me, and I'm an ex-CTO of a global cybersecurity company where we were really pushing the boundaries of what's being offered in the security area for small businesses and medium businesses. But what I've learned there and what the technology I applied there, we've been slowly applying to Civo as well to give a really secure public cloud platform. So today, security in the cloud, I think we can all agree that Kubernetes has won the battle for public cloud computing. I think either companies are using it today, pushing forwards today, but actually I think the future of the cloud is also Kubernetes, with SaaS providers using it to power their software under the hood. And as we move towards almost a no-code kind of web industry, I think Kubernetes will still be there in the background. I think it's then really important that the security around this is really paid close attention to. At the moment, a lot of trust is being handed over to cloud providers. And what I mean by this is running Kubernetes and running infrastructure on top of Kubernetes are really different problems. And most businesses today don't get a lot of value out of running Kubernetes themselves. So we've seen a move of managed Kubernetes clusters and the control plane in particular being handed over to cloud providers. This includes the running of the control planes, then ensuring the updates and security of the control planes as well. I think that's a point where there's been some security breaches recently, because these almost vendor managed components have either had components running within them that are insecure or have had a data breach, or that they're not being kept up to date. As end users, we don't normally get a lot of visibility of this. We're able to see what data we're running and put controls around that to stop attackers getting access to that data. However, the managed components are almost a black box and out of our control. I think that's where a technology from Intel, so SGX, really comes into play. As an introduction to SGX, it stands for Software Guard Extensions, and it allows the isolation of data and code at a CPU level. What I mean by that is when a piece of code starts running, a cryptographic key is created of the program and then the data that is used to load that, so any config files. That's then given to the CPU, which creates an isolated bit of memory that only the CPU with that key has access to read and write from that area of memory. This is called an enclave, and again gives you a lot more security around what is running in that program. Not only is the data protected at runtime, we have the ability externally to attest that the code and that config that is in that enclave is valid at any point. And we can do this as an end user either on the system directly or remotely, and that's called attestation. SGX enclaves, I think, will help solve these two problems with control planes as we see them at the moment. So isolation is mostly achieved through containers. So that could either be a VM that the managed provider is running, or more cost effectively, containerization, things like Docker containers or OCI containers, which is great. However, there is the ability in certain situations for a breach to happen where an attacker can run code across containers. And actually one of the other bigger problems is that as an end user, we're unable to verify that the code that should be running inside these control planes is the actual code that it should be. By this I mean that upstream Kubernetes will be deploying and giving out a secure or a verified version of the control plane components, but in a managed cluster we're not able as an end user to confirm that that is actually what's running, and that a cloud provider hasn't intentionally or unintentionally changed what is running. What SGX allows us to do is move these components like API server, controller manager, and scheduler into enclaves, and then from the outside get a cryptographic key that shows what code and what components are running in that. So this is what I'm showing here. On the left hand side, the traditionally managed way of running things with everything running inside a container. And on the right, where for every customer's API server and controller, it's running in its own enclave and it has its own ability to be attested. I'm going to swap over to a demo now. So just to give you an overview, we're using a program called Oculum, which is a micro VM that allows you to transport existing code into an enclave and give you some really nice wrappers around that. That includes things like creating the initial signing keys as well, so that when code is loaded into an enclave, it can be cryptographically verified. So I'll be spinning up a new Kubernetes API server using kubeadm, then moving the API components of controller, scheduler, and the manager over and into an enclave, and then demonstrating that kubectl still behaves as expected and we're able to spin up new components. So just swap over to my terminal here. First thing that we'll do is we'll just use kubeadm to create a new cluster. And then we'll use kubectl to show that we have a new cluster that is 8 seconds old. What we'll then do is we will move the components, so this will be the API server, the controller manager, and the scheduler outside of management by kubelet and stop them running. So now if we do that same kubectl get nodes, we'll see that the API server is down. We'll then come over here and we'll start these up inside a secure enclave. So we've got a wrapper script here for Oculum that will create an enclave, we'll move the kube API server binary over into it, and the config files for the CA certs that we've just created, and then start that running. So now that that's running, our get nodes commands will now show that that API server is up and running and accepting connections. We'll then go over and we'll start the other components, which is the controller manager and the scheduler. So these will run inside their own enclaves on the system. While that's running, we will untaint the control plane just because we're running a single node at the moment. And we'll create flannel as well, just so that we've got some initial networking on the machine. So once the scheduler and controller manager start up, we will see that the pods for flannel will get scheduled. Now that flannel is up and running, I have a very quick hello world deployment here of Nginx, a config map that will show out hello world, and a service. So if we get those created, what we'll see again is now that Nginx has started up, and Nginx itself here is running inside a normal container without the protections of an enclave. However, with the confidential computing components that are already in place, this is something that an end user is capable of doing today. And finally, we'll just do a quick curl to show that the Nginx is there, it's up and running and responding to hello world. And we'll get the service as well to show that that node port is there on 30,001 as we just did the echo. So just a quick reminder there, we've spun up the API server, the controller manager, and the scheduler inside a secure enclave using Oculum. Thank you very much for watching the demo. I think there's a lot of work that we still need to do on this to get wider adoption on this. In particular, we've had to make some changes to the Kubernetes components to allow them to get built into an enclave compatible manner, So we are committed to working with the various SIGs to get this supported by default. Even if you are not using enclaves, these changes will provide you a more secure API that you can roll out. We're also going to be working on getting kubelet moved over into an enclave. There are definitely more challenges around that, which we will be working towards. And once we have kubelet inside an enclave, we'll be actually pushing those out onto all of the worker nodes in a managed cluster. That goes on to the ability for us to do automated attestation of not only the control plane, but of kubelet. And if there are any changes to the kubelet binary, it would allow us to either cordon the node or drain that node of workload, or even remove it out of the cluster, so that you know as a customer that all of the components have been unmodified and have been untampered. Now that could again be from a cloud provider or even a malicious user that's able to access the system and change either some of the settings in kubelet or even the kubelet binaries themselves. We're also going to be working on moving more and more operating system components out into enclaves, with the end goal of using technologies such as trusted boot to create an entire VM all with inside an enclave, and then layering on top these other components like API servers and kubelets to give you a fully protected system that you can use to run services over. If you have any questions about this, please reach out on Twitter or directly either to @CivoCloud or to myself, or alternatively on our community Slack.